Hello, my name is Andrew Coble, and this is my Project 10 presentation for CE 570. Starting out, we'll just do a quick overview of the objectives for this Project 10. Starting out, we need to define a displacement field on the body, UZ, calculate displacement gradient tensor, delta UZ, and then calculate linearized strain, which is that calculation to the right, and then define material properties C and V. Calculate strain tensor S of x is equal to that function, and then calculate strain energy density, and then verify strain energy stored in one part of the body, which is done by integrating that strain energy density. So on the bottom left, you'll see the displacement field that I defined, and then on the bottom right, you'll see the displacement gradient tensor that I defined as well. So this just points out my displacement fields for each of my bodies, and then as well as basically the body. The body is defined, the hemisphere, cylinder, and upright cone respectively, and that's from previous weeks, but just to remind you as well. So here is the derivation of the linearized strain tensor. So as you can see, it's delta U of Z plus delta U of Z transpose, and that calculation can be seen below. And then the box in red is the final result, and then also the linearized strain tensor for each of the bodies, hemisphere, cylinder, and upright cone, and the MATLAB code for each of those respectively. All right, on this slide, this just defines the material properties. C is 300 times 10 to the 9, and then V is equal to 0.2. And then just a reminder about the strain, and then also the calculation or the derivation of the Cauchy stress tensor. This is just a quick look at the body that I chose to calculate the strain energy on, and that was the middle body, which was just the cylinder. And then here's also the deformed shape from my MATLAB code on the right-hand side. All right, so on the left-hand side is the calculation of the strain energy density, which got me a value of 4.77 times 10 to the 11th, and then integrated that over the cylinder and got me a value of 1.92 times 10 to the 14th power, and that can be seen reflected in my MATLAB code, so this is verified. All right, for this week's MATLAB code overview, I'll start out by reviewing this part, which is just we have the parameters, tangent vectors, all the other stuff from the previous weeks, volume Jacobian, area Jacobian, and then as we get into the new content for this week, which is the displacement field, so this is body 1, which is just my hemisphere. Here's the displacement field, the linear strain tensor, and then we have our C value, and then also our V value, and then we move on to cylinder. Same thing, we just have the new displacement field added in, and then the linear strain tensor, then these two values below, and then the cone, which is our third body. Same thing, just displacement field and linear strain tensor added, and then finally we have displacement gradient, the displacement gradient, and then our scale and the magnitude. I'll run this real quick. Might take a minute to load. All right, so as you can see, generating in, here's my deformed shape and the vectors. And yeah, I had to set it at a pretty low scale and magnitude just so you can see a pretty obvious deflected shape or deformed shape without it being severe. Then X out of that real quick, and then you can see my command window output. There's a strain energy for each part, and then the total strain energy. Thank you.